Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 30th, 2025, about 11 days ago. This paper provides a comprehensive survey comparing over 20 different models in this rapidly evolving space. The paper is titled, A Survey on Vision Language Action Models for Autonomous Driving, and it really maps out the path towards smarter, more interactive autonomous vehicles. It traces the evolution from early models that only explain scenes to modern systems that can truly reason and act. Also, the authors shared a fantastic companion repository for this survey. It's an awesome list, essentially a living, curated collection of papers and resources on this topic. You'll find all the key models, categorized by approach, along with important datasets and benchmarks. It's a great starting point for this field. Alright. And to really visualize this shift, the paper includes a great diagram. It shows 3 stages. First, conventional end-to-end driving, which is like a black box. Sensor data goes in, driving actions come out, but with little explanation. Then, early vision language models were added for reasoning, but this reasoning was disconnected from the vehicle's controls. This created what the paper calls an action gap. Finally, the new vision language action models integrated all into a single, robust loop, where a component called an action decoder translates the model's reasoning directly into driving commands. Building on that, this next figure gives a great overview of the general vision language action model architecture. It's a 3-part flow. First, you have vision, which takes in multimodal input from cameras and other sensors to detect cars and map the environment. This feeds into the language component, where an LLM processes the scene to understand it and predict what might happen. Some models even use what's called chain of thought, a technique where the model verbalizes its reasoning. Finally, the action decoder translates this understanding into driving commands like trajectory planning, steering, and braking. And this next figure really illustrates that evolution over time, showing 4 distinct stages. First, you have the vision language model as just an explainer. It sees the road but can't act. Then, in the modular stage, language starts to inform what's called an action head, a special component that translates reasoning into driving commands. Next, we see the true end-to-end models, where multimodal sensor input, so from cameras, LiDAR, and so on, goes in, and driving actions come out directly. Finally, the most advanced stage adds enhanced reasoning, improving long-term planning. Okay, this table really puts some names to those stages we just discussed. It compares over a dozen representative models from 2023 to 2025. You can see the evolution right in the columns. Early models like Drive GPT-4 used a single camera and produced what's called low-level control, or LLC, which are direct steering and throttle commands. But as you move to 2025, models like Orion and Auto VLA use multiple sensors and output a full trajectory, or traj, a planned path for the car to follow, showing much more sophisticated, long-term thinking. Of course, to train and test all those models, you need massive amounts of data. This table highlights the key datasets and benchmarks that have fueled this research. You can see a clear progression from earlier datasets like BDD 100K for basic captioning to modern benchmarks like Bench2 Drive. This one is specifically for what's called closed-loop control, which means testing the AI in a simulation where its actions have real consequences. The newer data also focuses on tasks like trajectory planning and that chain of thought reasoning. So, pulling it all together, what this paper shows is a clear and rapid evolution. We're moving away from disconnected systems towards these truly unified vision language action models that close that action gap. These models can take in complex sensor data, often creating what's called a bird's eye view, a top-down map of the scene, and combine it with language to reason and act. While big challenges like achieving real-time performance and ensuring robustness still remain, the path forward is clearly toward more transparent and instruction-following autonomous vehicles. That's all for today's AI Research Roundup. Thanks for tuning in.